afternoon, everyone. My name is Megan Lowry. I am a Media Relations Manager at the National Academies of Sciences, Engineering, and Medicine. Thank you for joining us today for a webinar on the report that was just released yesterday, titled The Potential Impacts of Gold Mining in Virginia. You can now download a copy of the report and other supporting materials at nap.nationalacademies.org. A link to the report will also be available in a QR code throughout the presentation, and a recording of this webinar will be available immediately following the end of the session. For those of you who are not familiar with the U.S. National Academies of Sciences, Engineering, and Medicine, we are private, not-profit institutions that provide independent, objective analysis and advice to the U.S. to solve complex problems related to and inform public policy decisions related to science, technology, and medicine. For each requested study, panel members are chosen for their expertise and experience, and they serve pro bono to carry out the study statement of task. The reports that result from the study represent the consensus view of the entire committee and must undergo external peer review before they are released, as did this report. Before I introduce the members of the committee that are joining us today, I just want to go over a few reminders. Please note that this webinar is scheduled to last 1 hour, so we'll start off with a presentation from the committee chair, and then we'll open it up to any questions you may have. To ask a question, you can click the Q&A button at the bottom of your screen, and you could submit a question at any time during the presentation. So with that, I will turn it over to William Hopkins, who is the chair of the committee and professor in the Department of Fish and Wildlife Conservation at Virginia Tech. Dr. Hopkins, over to you.
Well, thanks, Megan. Welcome, everyone. My name is Bill Hopkins, and I serve as chair of the National Academies Committee on the Potential Impacts of Gold Mining in Virginia. Thank you for joining us today. For the next 30 minutes or so, I will provide a high-level overview of the committee's work over the last year, as well as our key findings. And then we'll have time for a few questions. I'm joined today by some of our technical experts from various fields who are here to help address your questions regarding the report. They will introduce themselves after my remarks. And just to remind everyone, this study was mandated by House Bill 2213, which was passed in response to stakeholder concerns regarding potential gold mining in Virginia. The study was sponsored by the Virginia Department of Energy and the National Academy's Arthur L. Day Fund. We were tasked to describe the characteristics of the main gold deposits in Virginia, and based on this, also describe the types of modern methods used to mine similar deposits in other states and countries. In addition, we were asked to evaluate the potential impacts of possible gold mining on public health and the environment in Virginia. And we were tasked to summarize Virginia's existing regulatory framework for gold mining and compare this to other states. If you're interested in seeing much more detail about our statement of task, the entire task can be seen on page 19 of the report. Now, in response to this task, the National Academies formed our committee, which was composed of 13 qualified technical experts from a diversity of backgrounds to include geology, mining engineering, environmental studies, and public health. It's important to note that we are not the only committee tasked with examining gold mining in Virginia. Part of House Bill 2213 is being addressed by a second committee, referred to as the State Agency Committee. The State Agency Committee worked independently from the National Academies Committee and was organized by the Commonwealth to focus on issues related to local equity, environmental justice, and public health concerns raised by potentially affected communities. The State Agency Committee's report will be submitted together with the National Academy's report to the state legislature on December 1st, 2022. Now, the National Academies Committee utilized a variety of methods to collect information over the last year, and then we relied on the technical expertise of the committee members and the Academy staff to interpret this information and develop consensus conclusions and recommendations. The committee held 6 virtual information gathering sessions that included presentations and discussions with representatives from industry, academia, community-based organizations, and state and federal governments. Committee members also toured several sites relevant to gold mining activities in Virginia, to include the Moss Mine in Virginia, as well as the Hale Gold Mine and the Brewer Gold Mine Superfund site in South Carolina. We also examined rock core from the Vaucluse Mine in Orange County, Virginia, and a gold exploration site in Buckingham County, Virginia. The committee also benefited from public input obtained through 2 town hall meetings and a tour of Buckingham County, where we heard from a variety of stakeholders. The committee carefully considered all information sources, including scientific studies, peer-reviewed publications, regulatory documentation, case studies, site visits, and public comments in determining the findings outlined in our report. Now, for context, Virginia has a long history of gold mining that dates back to the 1800s. Virginia was actually one of the first major gold producing states in the nation, with peak gold production occurring between the 1830s and 1850s. Gold production in Virginia sharply declined in 1849 with the onset of the California Gold Rush, and the last commercial gold mining occurred in Virginia in 1947. There has only been intermittent exploration and small operations over the last 70 years. Today, there's only one permitted gold mine in Virginia, the Moss Mine, which is a very small operation, less than 1 acre in size. Virginia's gold deposits occur mostly in the Piedmont, with some in the Blue Ridge. Here on this map, you can see the Piedmont region highlighted in green. Two regions within that, the Gold Pyrite Belt and the Virgilina District, where considerable gold has been mined historically, are also highlighted in gray, and the black dots represent locations of gold mines and prospects in Virginia. Gold deposits in Virginia are found in steeply dipping, low sulfide quartz veins. The deposits only contain 1 to 5% pyrite. Pyrite is, of course, one of the primary sulfide minerals of concern with mining. However, even though the gold deposits in Virginia have low sulfide content, they can sometimes occur in close proximity to massive sulfide bodies. These adjacent massive sulfide bodies are a concern because if they are disturbed during mining operations, they can produce acidic drainage and release potentially toxic metals into the environment. It is important to note that the amount of sulfide in ores and the proximity of gold deposits to massive sulfide bodies can vary widely, even within a fairly narrow geographic range. Finally, it is also important to point out that the committee found that the known gold deposits in Virginia are generally smaller than in other gold-producing states, like those in the West and even in nearby South Carolina. This means that the size of future mines in Virginia would likely be comparatively small compared to operations in these other states. The committee concluded that while it is possible that larger gold deposits could one day be discovered in Virginia, the probability of this is low based on the geometries of gold deposits in Virginia known to exist at this time. Now, based on the nature of gold deposits in Virginia, the committee then assessed modern approaches that are used to mine and process similar deposits in other states and countries. Starting off with the big picture, best practices for mine evaluation, planning, and operations typically use a full life cycle approach, where the entire life of a mining project is considered at the earliest stages. This means that a mine must be designed for closure and reclamation from the very beginning. It also means that stakeholders should be engaged at every step in the life cycle of a mine project. There are numerous best practices and voluntary certification systems for mining. The goal of these is to improve mining operations performance and reduce impacts to the environment and human health. However, while best practices can reduce impacts to air and water quality, impacts cannot be completely eliminated, and the remaining impacts may still be of concern to communities and other stakeholders, which just further emphasizes the importance of stakeholder engagement. What I want to do now is focus on this stage of the mine life cycle that I've just highlighted here in the diagram. I'm going to just briefly touch on a few of the key steps in a gold mining and processing operation relevant to possible mining in Virginia. It's important to recognize that it typically takes many years for a prospected site to be permitted as a mine, and the overwhelming majority of prospected sites will never develop into a mine. But once a mine is permitted, the first stage of a mining operation is extraction of the ore and surrounding rock. Given the shape and the nature of the known gold deposits in Virginia, the committee determined that shallow open pit mining could be utilized for near surface ores. Operators might develop multiple smaller open pits with shared mining infrastructure. For perspective, these pits might be similar in size to the Harvard pit at the Jamestown mine in California, which is about 2,700 feet long at its widest point and 500 feet deep. Pictured here to the right is an example of another relatively small open pit mine in Nova Scotia. Now, for deeper deposits, it is also possible that underground mining might be utilized. Underground methods would include those suitable for vein-type gold deposits. For comparison, the Kensington mine in Alaska represents the type of underground mining methods that might be utilized in Virginia. The Kensington mine consists of several spatially associated ore bodies that have been developed using a common processing infrastructure, similar to what could occur in Virginia. Now, following extraction of the material, it must be processed. The ore would likely first be crushed and ground to reduce particle size. The ore would then be concentrated using gravity methods or flotation. Given the relatively small size of the known gold ore deposits in Virginia, and thus the probable small scale of mining operations, the economic costs associated with building a processing plant on site might not be practical. Thus, it is possible that a mining operation would only produce a concentrate on site using either gravity separation methods, flotation, or both, and then ship that concentrate elsewhere for further processing. For comparison, this approach was adopted at the Jamestown mine in Northern California. They shipped their concentrates to Nevada for processing. And similarly, in the 1930s, the Melville gold mine in Orange County, Virginia, shipped its concentrates to the American Metal Company smelter in New Jersey for processing. The next processing step, whether conducted on or off-site, is the leaching of the ore with cyanide. This is the most efficient available method for recovering gold from ore, and in commercial operations in the United States, it has completely replaced the historical methods of using mercury to amalgamate gold, because use of cyanide is much safer than these older methods. And I'll come back to some of the problems associated with historical use of mercury in just a few minutes. Broadly speaking, there are primarily two types of cyanide leaching. The leaching of ore in large open piles is called heap leaching. While certain mines on the East Coast have historically used this method, like the Brewer and Barite Hill mines in South Carolina, this is typically more common in the arid western states. Alternatively, cyanide leaching can occur in tanks. One such tank is shown here on the right. Following leaching, either carbon or resin is then used to absorb and concentrate the gold. Following cyanide leaching, the gold must then be recovered. Typically, the gold is precipitated out of solution by electrolysis or other techniques, and then it is purified in the final smelting stage, which you can see here on the image on the right. Ore extraction and processing to recover gold produces large quantities of processed waste rock, which are termed tailings. This material can be stored in above-ground facilities, in pits, or places backfill in underground mines. There are multiple strategies for tailings disposal and management, which might include different ratios of solid and liquid components. Tailings might look like a pumpable slurry contained within a surface impoundment, like you can see here in the top image on the right, or they can be thickened before emplacement. Higher degrees of tailing thickening increases costs, but can also influence its geotechnical stability. The bottom image on the right is an example of filtered tailings, which typically have 80 to 90% solids. Above ground storage of tailings can be accomplished using a variety of acceptable modern methods, all of which can produce safe storage facilities, provided that high quality engineering and maintenance are applied consistently during the design, operation, and closure phases of the mine. Now, as shown in the previous slides, commercial gold mines are complex industrial operations. As such, they can have significant impacts on the surrounding environment, especially when not conducted using modern best practices and engineering standards. The committee was tasked to evaluate a variety of possible impacts from gold mining on public health and the environment in Virginia. The committee evaluated potential impacts in the context of the statement of task, the geological and environmental context of Virginia, and the availability of reliable engineering controls to mitigate the risk in order to identify which specific impacts deserved more detailed discussion in our report. The following slides discuss some of the most likely impacts of concern, as well as some that we found were unlikely to occur, but still warranted careful evaluation because they were raised by the statement of task and concerned citizens. The first potential impact that I want to highlight is the potential remobilization of mercury. As I mentioned a few moments ago, mercury was once widely used in Virginia in the 1800s to amalgamate gold at mine sites. Large quantities of mercury were often lost during the gold mining process, and previous gold mining areas and downstream rivers are sometimes highly contaminated with mercury as a result. Because mercury is persistent in the environment, it can be found in high concentrations in stream sediments and soils hundreds of years after mining activities have ceased. If a new mine were established on a historic mine site where mercury was once used to amalgamate gold, the legacy mercury could be excavated and re-released into surface waters unless appropriate extraction and processing circuits are implemented to fully capture the mercury. Mercury is a concern because it is highly toxic to humans, fish, and wildlife. One of its chemical forms, methylmercury, is also strongly bioaccumulated and biomagnified in food webs, putting high trophic level consumers at risk of mercury toxicity. The second category of potential impacts that the committee evaluated relates to degradation of water quality. As I mentioned earlier, many Virginia gold quartz vein deposits are low in pyrite, but some Virginia gold deposits are located in close proximity to massive sulfide deposits. When mining exposes sulfide-rich minerals such as pyrite to air and water, these minerals can oxidize to form sulfuric acid and dissolved iron. Unless there is sufficient alkaline content, the resulting drainage water can be acidic and create what is referred to as acid rock drainage. Acid rock drainage is extremely toxic to plant and animal life due to its acidity, its high specific conductance, sometimes referred to as high salinity, and high concentrations of heavy metals and other elements. Elements like aluminum, arsenic, cadmium, copper, lead, mercury, selenium, thallium, and zinc are a concern for plants and animals. And if found in drinking water, a subset of these elements, along with antimony, may be a concern for human populations. Chapter 4 of our report explains how the committee determined which elements were of greatest concern and summarizes the possible adverse effects of these elements on humans and other biota. A second potential impact to water quality is the release of nitrates. Gold mines typically use a combination of ammonium nitrate and fuel oil for blasting during mining. Under suboptimal blasting conditions, significant amounts of nitrogen compounds, primarily in the form of nitrates, can be released into surface and groundwater. This can pollute drinking water sources and pose some human health risks. In surface waters, excessive nitrates can also cause harmful algal blooms and eutrophication, a process that depletes oxygen and reduces pH in surface waters, thus creating inhospitable conditions for fish and other aquatic life. The final potential impact to water quality results from the use of cyanide for gold processing. Now, unlike mercury, cyanide actually breaks down very quickly in the environment, making it a much safer alternative than historic mercury amalgamation. However, cyanide is highly acutely toxic to most organisms, so it must be managed and treated carefully on site to prevent its accidental release into the environment. In addition, open impoundments that contain cyanide can also pose acute toxicity risk to wildlife attracted to these impoundments unless proper management and deterrents are in place. The third potential impact that the committee highlighted in the report is the possible catastrophic failure of tailings dams and cyanide solution containment structures. These failures are low likelihood events, but they can have significant impacts when they occur. If a tailings dam fails, this can lead to acute hazards and long-term ecological effects caused by the dispersal of toxic metals, which are persistent in the environment. If an impoundment holding cyanide fails, the cyanide poses acute danger to animals, especially aquatic life, and even humans if the water is used as a drinking source. However, as I mentioned moments ago, unlike metals, cyanide degrades in the surface environment relatively quickly, making acute toxicity of greatest concern. The committee concluded that if tailings and cyanide containment structures are not designed to accommodate high precipitation and flooding events, then the likelihood of these potential high consequence structural failures could increase due to climate change. The committee was also tasked to assess potential impacts of gold mining on air quality, and we focused our efforts on possible impacts to nearby communities. The committee concluded that fugitive dust produced from excavation activities, heavy equipment, and mine road traffic could be a nuisance that impacts the quality of life of affected neighbors. In addition, toxic fine particles and gaseous pollutants generated from fuel combustion and gold processing can be hazardous if released. But the committee concluded that the impacts of air pollutants on surrounding communities are expected to be limited, given the likely small scale of possible future commercial gold mining in Virginia that would lead to limited heavy equipment operation and traffic, as well as the technological advancements in recent decades that allow for effective dust suppression and control of hazardous air pollutants. Thus, the committee did not find evidence to indicate that gold mining in Virginia would significantly degrade air quality if appropriate engineering controls were in place. Next, the committee evaluated the possible adverse effects of gold mining on water quantity. Dewatering of an open pit or underground mine could lead to drawdown of the water table, but the exact magnitude of drawdown and the area affected depends on aquifer conditions and the proximity of household wells to the mine site. Of course, loss of groundwater could significantly affect the quality of life for residents near the mine site who rely on groundwater supplies. Thus, rigorous site characterization and modeling are needed to estimate groundwater impacts and to evaluate whether alternative sources of water or new wells need to be provided to local citizens. This is another example of where the committee found that public engagement and participation during the earliest phases of permitting is essential if impacts to the water table seem possible. Last, the committee evaluated cumulative risk to humans from co-occurring stressors. Human populations are exposed to multiple hazard types, including biological, physical, chemical, psychological, and social stressors. It's been established that chemical and non-chemical hazards can interact to affect human health in complex and dynamic ways. Importantly, these multiple interacting stressors can lead to asymmetric impacts within and between communities, and historically under-resourced and underrepresented populations are oftentimes those most affected. In light of the potential impacts of gold mining in Virginia that are outlined in these conclusions, the committee recommends robust site and project-specific analyses before permitting a specific gold mining project. These site and project-specific analyses are necessary in order to assess potential impacts and determine what mining operation procedures will be most protective of human and ecological health. Now, the final major task of the committee was to assess whether Virginia's regulatory framework is sufficient to protect air and water quality. At present, there are very few metal mining activities in the state, and there are no active large-scale gold mines. And as I mentioned earlier, little commercial gold mining has occurred in Virginia for the last 70 years. Given the current lack of metal mining activities in the Commonwealth, the present regulatory framework appears geared towards projects such as sand and gravel mining and not gold mining specifically. Although most of Virginia's mineral mining laws and regulations seem suitable for the types of mines now operating in the state, the committee concluded that the current regulatory framework is not adequate to address the potential impacts, those that I just outlined in the previous slides, from commercial gold mining. Gold mining raises a number of environmental and public health issues that merit additional attention and suggest a need for changes in laws, regulation, and guidance. On the following slides, I will outline several areas that the committee concluded needed strengthening in Virginia's regulatory framework. The first topic is related to assessment of possible environmental impacts of a proposed mine. One of the cornerstones of environmental review processes, the National Environmental Policy Act, oftentimes referred to as NEPA, requires federal agencies to consider the potential environmental effects of a mine on natural resources, as well as effects on social, cultural, and economic resources before permitting. This figure you see here shows a simplified process for an environmental impact review. Virginia law does not currently require a NEPA-like review of environmental impacts for private lands, which is where gold mining is most likely to occur in the Commonwealth. This means that in the absence of a major federal action that triggers the federal NEPA process, there may be limited collection of baseline information and no formal documentation of the regulatory program's analysis or decision-making process. Some gold-producing states, such as Montana and California, have a state-specific NEPA-like process that allows for a consistent approach to collecting and considering baseline information and other material relevant to environmental impacts. Other states, such as Colorado and Nevada, have regulation, code, and guidance documents that emphasize the importance of baseline studies. The protection of air and water quality would be strengthened if Virginia adopted laws and regulations that required upfront, robust data collection and a NEPA-like analysis. The committee also found that Virginia currently has some exemptions that are not suitable for gold mining. For example, recall earlier that I mentioned the probable small scale of gold mines in Virginia might make it economically favorable to ship concentrates off-site for processing. Currently, gold processing facilities in Virginia that are not located on site with active mining would not require a permit from the mineral mining program for the operation and reclamation of the site. However, off-site processing may look very similar to permitted on-site processing facilities, and thus similar environmental impacts may result from them. While off-site processing facilities may be required to obtain permits from other agencies, the lack of regulatory oversight by the mineral mining program means that site characterization, project plans and designs, and the implementation of best practices for operations, reclamation, and long-term stewardship may not be adequately addressed. Some states, such as Montana, require permits for off-site processing similar to on-site processing facilities. As a second example, Virginia's current laws and regulations also exempt exploratory drilling for mineral resources. Impacts on the environment during initial exploration are generally minor, localized, and easily reclaimed. However, advanced exploration methods may be associated with greater impacts. For example, there are currently no mineral mining regulations for exploration in Virginia that mandate the plugging of drill holes or the covering of drill cuttings from the hole. If best practices are not utilized for these activities, some limited pollution of the local groundwater and nearby surface water could occur. This exemption for exploratory drilling also means that public notice to local communities is not required. Greater oversight of exploration drilling would ensure community participation starting at the earliest stages of the mine life cycle and would lessen the likelihood of these localized impacts. In some states like Montana, Nevada, and Colorado, drilling is a permitted and bonded activity that requires plans for operations and reclamation. The committee also identified shortcomings related to financial assurance. Virginia's bonding rates are based solely on disturbed acreage and are therefore insufficient to cover the costs associated with complex reclamation and long-term stewardship of gold mining and processing operations. This poses both a fiscal and environmental risk to the Commonwealth in the case of a bankruptcy of a mining company or abandonment of their mining sites. Virginia also offers a bond pool called the Minerals Reclamation Fund, with even lower per acre rates and pooled risk. The complex reclamation and long-term stewardship activities that might be necessary for some gold mining projects could greatly deplete or potentially even exhaust the Minerals Reclamation Fund used by the Commonwealth to guarantee reclamation. The committee concluded that regular recalculation of costs using verifiable engineering estimates would constitute an improved model for determining bonding rates in Virginia. The fourth topic that the committee evaluated was related to standards and their enforcement. Virginia's laws and regulations do not currently provide sufficient guidance for mine operators to achieve their objectives. And at the same time, they do not offer sufficient metrics for regulators to evaluate during the review of applications and inspection of mining activities. Fiscal and environmental risks to the Commonwealth would be reduced with improved guidance and performance standards on best practices for baseline monitoring, geochemical characterization, and water and tailings management. Additionally, the committee found that because of the lack of experience of Virginia regulatory entities in regulating metal and gold mining, regulators' current expertise with best practices may be limited. Last, the committee found key gaps in Virginia's capacity to implement and enforce some of its laws and regulations, such as the inability to directly issue penalties or fines for noncompliance without lengthy adjudication. Finally, the committee found that the current requirements for public engagement in Virginia are inadequate. Current Virginia regulations that are applicable to mineral mining will need to be amended to align with industry best practices and to reach the goals set out in the Environmental Justice Act, which was passed by the Virginia legislature in 2020. For example, only a limited number of residents are currently required to be notified, and current regulations only require a limited number of details in these notifications. In addition, Virginia does not specifically require the notification of tribal communities, which contrasts with industry best practices. In addition, there are no requirements in Virginia for public notice or opportunity for public input for exploratory drilling, or when an application is renewed, a permitted project is expanded or a bond is released. These permitting actions are critical milestones for the mining operations lifecycle, and they warrant meaningful engagement with nearby landowners, communities, and other stakeholders. Now, based on the previous conclusions, the committee determined that the present regulatory structure in Virginia is not adequate to protect against the potential environmental degradations that could accompany gold mining activities. Thus, the committee recommends that before gold mining proceeds in the Commonwealth, the General Assembly and state agencies should update Virginia's laws and its regulatory framework to protect against the potential impacts of gold mining. So just to summarize a few key take-home messages from the report that I just went over, gold mining raises a number of environmental and public health issues that are different from those posed by other types of mining activities. Best practices and modern engineering methods can substantially reduce risk of these possible adverse effects, but they cannot eliminate them entirely. The current regulatory framework in Virginia is geared towards projects such as sand and gravel mining and is therefore not adequate to address the potential impacts from commercial gold mining. The committee recommends that the General Assembly and the state agencies update Virginia's laws and its regulatory framework. As I mentioned, our report identifies problems with Virginia's bonding system, public engagement, environmental impact review, and a variety of other safeguards to mitigate the possible impacts from gold mining. Importantly, our report also provides concrete guidance on how to address these problems by pointing to industry best practices, modern engineering methods, and specific strengths of regulatory frameworks in other states that should be useful to Virginia if commercial gold mining were to resume in the Commonwealth. So that wraps up our high-level summary. You can download the full report for free using this QR code, or you can just go to the National Academy's website. And now I would like to turn to my colleagues that were on the committee, our technical experts that are here today, and have them introduce themselves before we take some questions. Thank you very much. So let's see who I can see here. Garrett, would you like to introduce yourself, please?
Hi, good afternoon. My name is Garrett Smith. I'm a geochemist with the Montana Department of Environmental Quality, and the specialty I brought for this committee deals with mining regulation, particularly for hard rock and gold mines.
Thank you, Garrett. Kwame?
Hello, everyone. My name is Kwame Ewofe. I'm a mining professor at Missouri University of Science and Technology. I'm a mining engineer, so that's the expertise I bring, and I also work on sustainable mining practices.
Wonderful. Thank you, Kwame. Is Fiona still with us?
Good afternoon, everybody. I'm Fiona Doyle. I'm a professor emerita at the University of California, Berkeley. Academically, I specialize in the processing of minerals and materials, and this includes a lot of gold processing.
Thank you, Fiona. And we may be joined by one other committee member in a few minutes, but why don't we go ahead and get started, Megan?
All right, thank you so much. As Dr. Hopkins said, we're going to get started with Q&A now. So just a reminder, if you haven't asked a question yet or you want to, you can just click the Q&A button at the bottom of your screen and type in your question there. All right, our first question today for the committee is going to be, based on your report, would you recommend the state or local government deny any requests for a permit to open a gold mine in Virginia?
Well, so I'll start off and see if any of the other committee members want to chime in. So basically, our report very clearly suggests that the regulations, the regulatory structure, the gaps that I pointed to just moments ago need to be filled. There need to be market improvements in several areas before permitting a new mine. And so that covers everything from the bonding issues that I brought up to the initial impact assessments to stakeholder engagement. Garrett, would you like to chime in on that as well?
Certainly, Bill. So within Chapter 5, there is some discussion about local permitting requirements, talking about zoning requirements and often some kind of special use permits that would be required. So that is one part of the permitting process. So a potential mine applicant would need to work with local authorities, but also receive state permitting authorization. So there's kind of a multiple pronged approach to that permitting. And as Bill said, our report really focused on the potential for a broad range of sites. So we're really not in a position to speak to particular impacts at a particular location. Gold deposits, gold mines, and methods can be highly variable. So our recommendations are really focused on those site-specific details and analysis. So any permitting body, whether local or county or state, needs to evaluate the project in its entirety and consider baseline studies, potential impacts, before making any kind of call about whether something should or should not be approved. And that really wasn't the role of the committee.
Great points, Garrett. Thank you.
Great, thank you all. Our next question is, did your committee recommend any specific ways to prevent harm from cyanide?
Yeah, I'll start us off on that. Oh, Fiona, would you like to? Go ahead.
Yes, I'll jump in on that. We very specifically pointed to best practices, such as those that have in fact been developed and codified by the mining industry itself, and pointed to the successful record that has been achieved at mines that self-certify that they will be using best practices.
Thanks, Fiona.
Thank you. Our next question is going to be, are you aware of any modern gold or metal mining operations that do not adversely affect the environment?
Well, so coming back really to, I think, Garrett's point a minute ago, we did not conduct, the charge of this committee was not to conduct an in-depth analysis of any specific mine or any specific state regulatory structure. Instead, what we did was we really took a broad view and tried to pick out some worst case scenarios and some best case scenarios, where things have gone wrong and where mines or where state regulatory frameworks really seem to be excelling and preventing those sorts of bad things from happening. So I think one of the strengths of our report is that we sort of point to lots of examples without getting into the weeds of a full-on assessment of any particular mine. Go ahead, Fiona.
Yes, I would say that one can't point to any human engineering activity that does not have an impact on the environment. And engineering, building roads, building bridges, developing housing, in all of these, it basically looks at the benefits and looks at whether the benefits outweigh any impacts. So I think that the same principle should be applied to any prospective mines.
Thanks, Fiona. Go ahead, Kwame.
And I just want to say that any reader who reads this report and the work that the committee has put together, really, we all need to come to this focusing on the charge that we were giving and what the report was about. And the work of this committee was to look at Virginia's regulatory framework, to look at the particular geologic context of Virginia and review whether or not the regulatory framework is adequate and what will be potential impacts of gold mining. And I think that's what the report is about. And there is a lot of good things in there for state agencies and the Commonwealth to look at what we've recommended. And it really wasn't the point of the report, as others have said, to look at, whether or not there exist mines that have negative or positive impact. Our work was to review the particular geologic context, look at what the potential impact could be, and maybe some things that could be done to mitigate those impacts, and whether the regulatory framework was adequate to support metal mine or gold mining in Virginia.
All great points from everyone. Thank you.
Great, yes, thank you. Our next question is, do you recommend monitoring of current mines or former mines in perpetuity?
Garrett, do you want to talk about closure, maybe? Closure of mines?
Yeah, certainly. So some of this is discussed within our report, within Chapter 3, where we discuss methods for engineering, reclamation, and monitoring. And then it's also discussed a bit within Chapter 5 in looking at permitting and what do reclamation plans look like. And again, because we were not focusing on a particular project, we can't speak to the monitoring requirements for a particular facility. We do provide examples and we discuss scenarios in which that might be necessary. It really depends on whether or not there are pit lakes or underground workings that need groundwater or hydraulic monitoring or hydrologic monitoring. There may be waste management areas like rock dumps or tailings facilities that again require some level of oversight. So that monitoring component is very critical though for a reclamation plan. And those kinds of details need to be evaluated in advance. And I think Bill's slides really demonstrate that life cycle for a project very well, in that before a mine is permitted to begin operation, the closure and reclamation steps and other monitoring and that really long-term stewardship, that all needs to be evaluated in a part of that assessment prior to permitting a project. So long-term monitoring or water management could be required in some cases. Again, not all mines may need that. You really have to look at those site-specific details for the surrounding environment and the project details before making that kind of determination.
Thanks, Garrett. Anyone else want to chime in on that?
Let me do so, Bill. So as Garrett rightly pointed out, the report has assessments of various situations and how one might evaluate what the potential impacts would be, as well as what monitoring would be required. And I think the point I wanted to add to Garrett's answer is answering questions like this is why we think site-specific characterization and assessment of the project before a mine permit is issued is so important. Hence, our recommendation for Virginia's regulatory framework to be updated to ensure that such assessment occur before a mine is permitted, because one can't answer the question for all mines. It depends on the particular conditions, and you would not be able to provide that answer without doing the assessment first. And hence our recommendation to have a regulatory framework that ensures that regardless of whether the mining is occurring on public land or private land, such assessments occur.
Great points.
Thank you. Our next question is initial reconnaissance exploration drilling involves very small boreholes for core recovery. Should all exploration drilling, even initial drilling, require permits?
So I think I'd come back to how some other states are handling this and how that relates to our recommendations. Garrett, you want to point to what we see in some of the Western states?
Sure. That there are examples elsewhere where any type of exploration activity does require some level of licensing or permitting. That could look like anything from trenches or some excavation work, access roads, again, drilling. And it's typically, core drilling, but it could also be reverse circulation or drilling where you're getting chips and bits of rock out of the hole. And in our report discusses this both in Chapter 3 and Chapter 5. And we look at those different levels of exploration. Early on, preliminary work may be very minor, and there may be very small holes or very small surface disturbance. In other cases, in more advanced exploration, there may be many more holes and drill pads associated with that. And we also discuss the potential changes to water quality or quantity related to the drill hole itself versus any kind of cuttings or disturbed material around the holes. So we do point to examples elsewhere of some impacts from exploration work, and also that other states do require some level of permitting and bonding. They require some type of financial assurance for plugging and abandoning holes properly and making sure that those surfaces are reclaimed. I will note that in Virginia, all other exploration work is also required to obtain a permit. So trenching, excavation type work would require permitting, but in Virginia, drilling is specifically exempt. So that is different than what we see in other states.
Thanks, Garrett. Go ahead, Kwame.
Yeah, I was going to add that one of the things we point out in the report as a benefit for requiring permits or some kind of licensing for exploration work is it allows for community engagement very early in the project, because with a permit application, you can engage the public on this. So whether or not Virginia chooses at what stage to require permits, we point out in our report that the benefit of doing an early stage permit is that you can also start community engagement sooner rather than later.
Thanks, Kwame.
All right. Our next question is, would best practices that work well in the West also work well in the East, where the climate is more wet and prone to storms like hurricanes and tropical storms on a much more regular basis?
That's a great question, and I'm glad it was asked. I think a lot of people here are going to want to weigh in on that. Let me start us off by saying this really gets to, one of the challenges that we've already touched on with our statement of task, and that was to look at Virginia widely and to try to find analogous situations elsewhere, similar deposits, similar hydrogeology, similar weather patterns, and so on. And that's challenging because even if you go to South Carolina, which is fairly similar in terms of precipitation patterns and some of those things, the gold deposits there are actually much larger. So we had to draw from lots of different places and lots of different examples to try to make some of these generalizations about Virginia. The point about increased precipitation in Virginia creates a very, very different scenario for certain activities at a mine site, like tailings management would be one of those. You've got to consider the impact of potential increased frequency of flood events and hurricanes and those sorts of things. But let's let others weigh in. Fiona, go ahead.
It's a great question, and I would say that best practices always consider the climate and not just the total amount of precipitation, but the seasonal precipitation, temperature as well. And so the engineering approach that would be a best practice for an arid region would be different from that in a region that has more precipitation. But certainly there are many best practices that have been developed for gold mining and processing in areas with heavy precipitation.
Thanks, Fiona. Would others like to weigh in?
I think that some of the guidance documents or other regulations that we cite within the report take some of that into account, as Fiona said. When we're talking about different type of cover systems for reclamation or long-term management of pit lakes or water balance, we do acknowledge the climatic differences between Virginia and the East Coast and some other states within the West. But again, we're pointing back to this requirement or this recommendation to really look at those site-specific characteristics and considering storm analysis. And with a dynamic climate, how do we anticipate future storm events or flooding, and how is that built into the engineering designs?
Terrific. Thanks, everybody.
All right. Our next question is, regulations that are enforced are typically minimum requirements. So while best practices are nice, are they enforced as though they were required?
Kwame or Garrett, would one of you like to take that one?
So correct. The person posing the question is correct that regulations are often, or regulatory standards are specified as minimum standards, and then the company can exceed those minimum requirements. But also permits are issued with permit performance conditions that the regulator, after taking all the information into consideration, and I'm sure Gary can share experiences from Montana, for example, that just because there's a particular regulatory standard does not mean after looking at that particular project and the site-specific conditions, as well as what the proponent is planning to do, you cannot impose certain permit conditions. So it is important, and that's part of why, again, I'll come back to that recommendation to require site characterization and rigorous site characterization and update the regulatory framework so that the people who review these things are well equipped and well trained to be able to look at that particular project and all the data that comes from the characterization to then be able to write permits that have the right permit conditions in order to manage any possible or mitigate the possible impacts that mining activity could have. So while that is correct, again, in most jurisdictions, you have the data and then you go through and end up writing a permit that imposes permit conditions on the operator.
All right, thank you.
If I could add to that, one of the things we discuss within Chapter 5 is that capacity to regulate. And this has to do with not just staffing and expertise, but also coordination with other departments, because you have other programs around the Commonwealth that would be permitting water quality, water management, discharge systems, air quality, in other areas. So that's one thing we point out, is that needs to be ensured through communication and coordination among departments. Inspection frequency, inspection of facilities by qualified engineers for tailings impoundments. We hit on some of these points that again are ensuring that compliance. And as Kwame said, there is always room for companies to perform beyond those and put in additional safeguards and maybe even meet lower standards if necessary.
Thank you both.
Thanks. Could you share with us a little bit about what your experience was like as a committee this past May in meeting with impacted citizens and touring a couple sites in Buckingham and in the Commonwealth? And how did these visits affect your report?
Yeah, so I think they had, I think I speak for everyone on the committee when they were crucial to our process. They really helped us understand the types of concerns that citizens near a prospected site might have in terms of their water, in terms of their quality of life, in terms of their air quality. And although we were not specifically focused on the Buckingham County situation, it obviously gave rise to this study, but we were looking at the state more broadly. We heard most of the concerned citizens that we heard from were from Buckingham. And I will say that listening to them, hearing their concerns firsthand was extremely important, because it raised things, for example, like stakeholder engagement. The whole stakeholder engagement thread, you see it throughout our report, how important that is, the communication. We heard that over and over again in town halls. And so I think that you look to other states, and stakeholder engagement is a crucial part of the mine life cycle. Right now, that's not really required, or the requirements are very lax in Virginia. And so I think some of the upfront communication in Buckingham would have probably helped with some of the concerns that we heard. But let's hear what others have to say, because these were very impactful discussions. Go ahead, Fiona.
I would echo Bill's observations. It was incredibly educational for me to hear, particularly in comparison to California, where I am, how different stakeholder engagement is in Virginia. And I would like to sincerely thank everybody who participated in town halls and listening sessions. It was very educational for me.
And if I could add to that, I think it's interesting to note the different procedures or requirements for stakeholder engagement within different states. And yet one of the things that stood out to me is just how similar the stakeholders are. In Montana, when we're permitting projects, local communities, tribal communities, folks have the same concerns regarding water quality, water quantity, air quality, noise, lights. They have questions about the projects. They don't understand mineral extraction completely. So I really see a benefit when we have public meetings and interact with stakeholders to share that information. So it was enlightening for me to see the folks that spoke up in Virginia have very similar concerns to what we see elsewhere. And as others have noted, we see that kind of disparity in the engagement process, though, for permitting. So that was a very common thread throughout our report.
Thank you.
Thank you all. It looks like we've got a couple minutes left, so I'll just pose one more question to the committee. What are you most hoping that Virginian communities and other communities that could be impacted by possible gold mining, take away from your report now that they have the final copy?
Anyone want to take the lead on that?
If I could start,
Go
a
ahead.
common theme for me and what I take home from the report is that the known deposits and the geology within Virginia, there's some variability. So not every deposit is the same, and therefore not every mine that might be developed at that deposit would function or operate in the same way. And the communities and the concerns of stakeholders around those areas are very different. So one of our key recommendations is that regulatory entities really need to evaluate projects based upon very specific characteristics, and there needs to be a robust analysis of that particular site and those communities and those proposed mining plans. It's very difficult to depict gold mining as one thing in one location because it can be quite variable. So that was a real common theme for me throughout the document.
Excellent point, Garrett. Go ahead, Kwame.
So I would, it's a good, very good question. And I would start by saying that people who aren't familiar with mining projects often think if there is exploration, it leads to mines. And I think one thing I would want to get across is a lot of exploration projects, in fact, majority of exploration, an overwhelming majority of exploration projects do not lead to mining projects to begin with. And so I think there is a continuum to things, and a lot of times exploration starts and it doesn't lead to a mining project, because for a mining project to exist, there needs to be a viable, economically viable mining project. That's one. And the government and the people need to be willing to permit that project and allow that project to go forward. That process requires stakeholders, that some of which were mentioned, local communities, the mining companies, the representatives of the people through the legislatures to say we want mining to go. And I think what this report has done is provide a framework for the Commonwealth to decide that if it wants metal mining, if it wants gold mining to proceed, these are some things that can be done, from beefing up regulatory standards, providing resources to those who regulate mining, ensuring some of these things are in place so that when mining occurs, the people are protected, the ecology is protected as a result of that. So I think the takeaway from my perspective is to take the report and use that to facilitate mining that is beneficial to, as much as possible, to all stakeholders in the end.
Thank you, Kwame. I think they covered it. Fiona, wonderful. Go ahead.
Yeah. I mean, my takeaway is that the people of the Commonwealth deserve the best. And if mining is to happen, it should absolutely follow best available technology, and that there should be accountability, to ensure that it's done responsibly.
Very well stated.
Great. Well, thank you all so much. Unfortunately, it looks like those are all the questions that we have time for today. I will note again that a recording of this session will be available as soon as we are done here on the National Academy's website. So with that, I'd like to thank our speakers and thank you all again for participating and joining us today.